Your quiz is on section 1.8. So everything that's on here is like fair game for what's on your quiz. For number 1, you have 7 minus the absolute value of 2x minus 5 is equal to negative 27. Remember, when you have that equal sign, that you're going to isolate the absolute value, then form two equations without the absolute value involved, and solve both of them. Remember, the absolute value of anything is always a positive number. It can never be equal to a negative number. So if that's ever given a case for you, it would just be no solution. So with this one, we're going to move the 7 over first by subtracting it from both sides. That gives us the opposite of the absolute value of 2x minus 5 is equal to negative 20. Or sorry, negative 34. Then from there, we're going to divide the negative out of your left side to just have the absolute value of 2x minus 5 is equal to positive 34. Because this is equal to a positive number and our absolute value is isolated, we can separate this into two equations and solve both of them without the absolute value. So that's going to give us 2x minus 5 is equal to negative 34. And 2x minus 5 is equal to positive 34. So one stays the same, the other just changes the sign on the answer. So from here, we are going to work with the one on the left first, add the 5 over. So that gives us 2x is equal to negative 29. We divide each side by the 2, and we have that x is equal to negative 29 over 2. For the other, we move the 5 over, adding it to both sides. Oops. All right, so from here, we're going to have 2x is equal to 39. And then we divide each side by the 2. And we get that x is 39 over 2. So both of these are your answers. For number 2, you're going to start this one by dividing each side by the 2. So that's going to give you the absolute value of 5x minus 1 is equal to 2. Your absolute value is isolated from here, so you're going to form two equations without the absolute value. So you're going to have 5x minus 1 is equal to negative 2, and 5x minus 1 is equal to positive 2. I'm going to work with the one on the left first, adding my 1 over to get 5x is equal to negative 1, and then divide each side by the 5. So x is equal to negative 1/5. For the other one, I'm going to add the 1 over to get 5x is equal to 3. Then I'm going to divide each side by the 5. So we have x is equal to 3/5. So you have negative 1/5 and positive 3/5 for your answers for this one. For number 3, you have the absolute value of 3x plus 4 minus 5 is equal to 3. For this one, we're going to add your 5 over first. So that's going to give us the absolute value of 3x plus 4 is equal to 8. From here, our absolute value is isolated. It's equal to a positive number. We are going to separate this into two equations. So we're going to have 3x plus 4 is equal to negative 8. And 3x plus 4 is equal to positive 8. We are going to move the 4 over by subtracting it from both sides, and I'm going to work with the one that I have on the left first. So that's going to give me 3x is equal to negative 12. And then we're going to divide each side by the 3 to get that x is equal to negative 4. For the 3x plus 4 is equal to 8, I'm going to subtract the 4 over. That gives us 3x is equal to 4. Then I divide each side by the 3 to get x is equal to 4/3. So I have negative 4 and positive 4/3 for my answers. For number 4, you have negative 1/5 times the absolute value of x minus 16 minus 6 is equal to negative 4. For this one, we're going to add the 6 over first. That's going to give us negative 1/5 times the absolute value of x minus 16 is equal to 2. From here, in order to get rid of that negative 1/5, we're going to multiply each side by negative 5 over 1, which is the reciprocal. So that's going to give us the absolute value of x minus 16 is equal to negative 10. Our absolute value is isolated, however, it is equal to a negative number. So because it's equal to a negative number, it's automatically no solution. For number 5, you have 5 plus the absolute value of 2/3 x plus 1/2 is equal to 13. For this one, I'm going to start by subtracting my 5 over. So it's going to give me the absolute value of 2/3 x plus 1/2 is equal to 8. Our absolute value is isolated. It's equal to a positive number. So I'm going to separate this into two equations. One's going to give me 2 over 3x plus 1/2 is equal to negative 8. The other is going to give me 2 over 3x plus 1/2 is equal to positive 8. Now, I don't like working with fractions, so if it was me, I'd multiply my entire equation for both of these by 6 to get rid of my fractions. So it's just the least common denominator. I have 3, I have 2. Their least common multiple is 6, so I multiply everything by the 6. For the equation on the right, it's going to give us 3 times 2, 3 goes into 6 twice, so 2 times 2 is going to give us 4x. The 6 times 1/2 is 3, and the negative 8 times 6 is negative 48. From here, we are going to move the 3 over and subtract it from both sides. That gives us 4x is equal to negative 51. We divide each side by the 4, and we get that x is negative 51 over 4. For the other one, we multiply by 6. The 6 divided by 3 is 2, so 2 times 2x is 4x. The 6 times 1/2 is 3, and 6 times 8 is 48. We're going to move the 3 over by subtracting it from both sides. We get 4x is equal to 45. We divide each side by the 4, and we have that x is 45 over 4. Your next section goes over inequalities and solving these inequalities. You are graphing the answers and stating your answer in interval notation. So same as your equations, first I isolate the absolute value. Before you do anything with it, look at what you have. If the absolute value is greater than a negative number, that's always going to be true. So it's going to just be all real numbers. If the absolute value is less than a negative number, that's never going to be true. It's going to be no solution. So in example 6, you have 2 times the absolute value of 4x minus 1 plus 3 is greater than or equal to 9. We're first going to move the 3 over by subtracting it from both sides. That's going to give us 2 times the absolute value of 4x minus 1 is greater than or equal to 6. From here, divide each side by the 2. So that's the absolute value of 4x minus 1 is greater than or equal to 3. The absolute value is greater than or equal to a positive number. We're good. We can separate this into two inequalities. Get rid of the absolute value bars, change your answer, keep one the same. Bless you. Remember, when you change your sign on your answer, your inequality sign flips. So this is going to give us 4x minus 1 is less than or equal to negative 3, as well as 4x minus 1 is greater than or equal to positive 3. For the one that I have on my left, I'm going to add my 1 over first. That's going to give me 4x is less than or equal to negative 2. Then I divide each side by the 4. And I have that x is less than or equal to negative 1/2. For the one that's on my right, I'm going to add my 1 over. That's going to give me 4x is greater than or equal to 4. Then I'm going to divide each side by the 4 to give me x is greater than or equal to 1. So on my number line for this, I'm going to find my negative 1/2. I'm going to find my 1. My negative 1/2 is equal to, so I'm going to put a closed circle on that. Because my x goes first, my sign points to the left, my line runs to the left. With my 1, also has a line underneath it, which means it includes it, so that's going to get a closed circle. Line's going to go to the right, since when x is first in the inequality, the sign points to the right. Your interval notation from this is going from negative infinity up to negative 1/2, including the 1/2, so, or the negative 1/2, so brackets go on it, with a union of 1 to positive infinity, with the bracket on the 1 as well. So this whole thing would be part of your work, and your answer is what's on the right side. So you have your graph and your interval notation. For number 7, you have 8 times the absolute value of x minus 1 minus 4 is less than 2. For this one, we're going to start by adding our 4 over. That gives us 8 times the absolute value of x minus 1 is less than 6. From here, we divide each side by the 8. We are left with the absolute value of x minus 1 is less than 3 over 4. Absolute value is isolated, less than a fraction that's positive, that's fine. Separate this into 2 inequalities. You're going to have x minus 1 is greater than negative 3/4, and x minus 1 is less than positive 3/4. Add your 1 over. That's also 4 over 4. So it's going to give you x is greater than 1/4. Same thing with the other one. Add 4 over 4 to both sides. That gives you x is less than 7/4. On your number line, you're going to have a 1/4. You're going to have a 7/4. Your 1/4 does not have an open, or sorry, has an open circle on it because your sign is not also equal to, and your line's going to go to the right since your sign points to the right when x is first in the inequality. For your 7/4, it's going to have an open circle, and your line's going to go to the left because x is first in the inequality and your sign points to the left. These overlap in this section here, so I'm going to darken this, and I'm going to cross out what's to the left and the right of that, which means for my interval notation, I'm going to go from 1/4 to 7/4 and have parentheses on both of those. For your next question, you have 10 over the absolute value of 2x minus 6 is less than or equal to 5. I don't want the absolute value in my denominator, so I'm going to isolate it, but first I'm going to take it out of my denominator, so I'm going to multiply each side by the 2x minus 6 inside the absolute value. It's going to cancel out on my left side, so that's just going to give me 10 is less than or equal to 5 times the absolute value of 2x minus 6. Again, I want to isolate that absolute value, so I'm going to divide each side by the 5, and that's going to give me 2 is less than or equal to the absolute value of 2x minus 6. My absolute value is isolated. It says that it's greater than 2. That's fine. I'm going to rewrite this, giving myself 2 inequalities without the absolute value. So I'm going to have negative 2 is greater than or equal to. I change the sign on the 2. I flip my inequality sign to x minus 6, as well as positive 2 is less than or equal to 2x minus 6. From here, I want to get x by itself. And I want to make sure x is on the left side, so that way I know which way to draw my lines for my number line and my inequalities. So I'm going to first move my 6 over by adding it to both sides. So that's going to give me 4 is greater than or equal to 2x. Then I divide each side by the 2, and that's 2 is greater than or equal to x, which if I flip this to make sure x goes first, my x is going to be on the left side. My 2 is going to be on the right side. My sign is open to the 2, so it's going to stay open to 2. So it's just going to be x is less than or equal to 2. For the other side, I'm going to move my 6 over first, just like I did on the other one. So that's going to give me 8 is less than or equal to 2x. From here, I divide each side by the 2. So that's going to give us 4 is less than or equal to x, which again, we rewrite. X goes on the left, 4 goes on the right, sign's open to x. It's going to stay open to x. So on our number line, 2 is going to go to the left, 4 is going to go on the right. The 2 is going to get a closed circle because it has the line underneath the inequality, so it's equal to. And then my sign points to the left when x is first. My line's going to go to the left. For the 4, again, closed circle on the 4 because it's also equal to. When x goes first in our inequality, your sign points to the right, so your line's going to go to the right, which means the interval notation on this one is going to go from negative infinity up to 2, including the 2, so bracket on the 2, with a union of 4, including the 4, so bracket on the 4, comma, infinity. For number 9, we have negative 14 times the absolute value of 2x minus 7 is greater than or equal to 28. For this one, we're going to divide each side by the negative 14 first. Again, we are dividing by a negative, so we flip that inequality sign. So we're going to have the absolute value of 2x minus 7 is less than or equal to negative 2. We have the absolute value of something is less than or equal to a negative number. There is absolutely no case where the absolute value of something which becomes a positive number is less than or equal to a negative number. So because this is never true, this one is no solution. All right, so for number 10, we have negative 2/3 times the absolute value of 4x plus 8 is less than 1. So if we were to simplify this, we're going to multiply each side by the negative 3/2 to cancel out those fractions. Change your inequality sign at the same time. So you're going to have the absolute value of 4x plus 8 is greater than negative 3/2. Now with this one, you have the absolute value of anything, of something, is greater than a negative number. So because it's greater than a negative, so you're going to have a positive number is greater than a negative number. This case would always be true. So since it's always true, it's going to be all real numbers. So if you remember to write that in interval notation, it would go from negative infinity to positive infinity. Let's do something like those we just did equal ones. So we're going to have something like the absolute value of 3x plus 7 is equal to the absolute value of 2x minus 1. Okay. So with these types of equations, you are going to get rid of the absolute value bars because there's no way to isolate them. Get rid of them, distribute a negative into one of the two equations that you make. So one's just going to be 3x plus 7 is equal to 2x minus 1. The other one is going to be 3x plus 7 is equal to the opposite of 2x minus 1. And then, like I said, you just solve both of them. So if we work with the one on the left first, we're going to subtract the 2x from both sides. That gives us x plus 7 is equal to negative 1. Then you subtract your 7 over, and that gives you x is equal to negative 8. So that's one of your solutions. For the other one, we would start by distributing that negative in. So that's going to give you 3x plus 7 is equal to negative 2x plus 1. From here, I'm going to add the 2x over. That'll give us 5x plus 7 is equal to 1. Then I'm going to subtract the 7 over, leaving us with 5x is equal to negative 6. And then divide each side by the 5. So we have x is equal to negative 6 over 5.